Hey everyone, Mr. Voikin here, Unit 7, Lesson 5. We've already done a lot of these questions in class, but I just want to go through a few of them with you and just again emphasize the importance of getting a graphing calculator. The TI-84 is a good one that a lot of people will be using and I will be using, so you'll be able to follow along with me. No problem here. I will be giving you a link to a series of 4 YouTube videos that I found that explain all the different functions of this calculator quite well. And it's definitely in your interest to learn how to use this tool. So not only will you be using it in my math class, but also in grade 11, 12, and into university. So the better that you understand this calculator and the more functions that you can use, the quicker and more efficient you're going to be when working on your math questions. Now, in the book itself, which is starting right here on page 433, it goes through some of the main sort of functions that we can use when we're graphing. And there's about 9 or 10 pages of that. So definitely you want to go through that and again, use this and the videos that I will be posting to you and make sure that you become proficient with the calculator. Otherwise, I'm going to start off here with the assignment on page 442, but I'm going to skip down to question number 3. And in this case, they're just saying, here's some functions. And I'm going to tell you that I'm going to give you the value of x and I want you to calculate the value of y. So if I go back to this screen right here, you can see it's telling me that y is equal to negative 2x plus 12. I'll tell you that right now x is equal to negative 17. So what is the value of y? So this is just simple substitution where I'm going to take my original equation and wherever the variable is that I'm going to substitute for, I just put 2 brackets and then finish the writing down the equation and basically take that substituted value and plug it in there. So I'm going to turn the calculator on and now all I have to do is literally type it in as I see it. So I want to use the negative sign down here, not the minus sign. So negative 2 bracket. And inside the brackets was a negative 17, and it's going to be plus 12, and I hit enter, and you can see that when I get this value right here of negative 17 on the x, that y is equal to 46. Now, another useful feature on this calculator, if I just go second and enter, it copies and pastes my original equation that I put in. And now I can just use these arrow keys to go back and I can delete that, move over again, delete that, and delete this. And now I can go second delete, which allows me to insert something and I can put a 9 in there. So I just modified that original equation, hit enter, and it tells me that when x is equal to 9, that y is equal to negative 6. Okay, so there's another function of the calculator that you'll definitely want to take advantage of, and that is this y equals button, where you can actually type in the original equation, which was negative 2, and the x is right here, x plus 12, and then I can graph it. So it's going to show me what the graph is going to look like. And I can see there's a whole bunch of points and intersections with the x and y axis, but I can't see exact values. So we're going to have to use some of the other features that are available in some of these buttons right here, and it'll allow me to see those values. So the easiest one right now is if I go second and graph, it brings up a table. And if I was to use the buttons and scroll all the way up to negative 17, you can see at the value of negative 17x, y is 46. And the second one I put in was a value of x equals 9. So we can scroll down to x equals 9, and in this case, y equals negative 6. Now, we can scroll up and down using these buttons, but if I told you right now to go find what is the value of y when x equals negative 2,451 and when it equals positive 5,009, you don't really want to be scrolling that many values. So there's a number of different ways to do it. The best way that I've figured out is just go to second and window, which is your table, and how you're going to set it up. So yes, you could just punch in right here that I want the table to start at negative 2,451. I could go look at that, come back into this, change that to 5,009. Or you can take this independent variable, and instead of auto-generating the table of values, we're going to ask for the independent variable and then tell you what the dependent variable is. So I'm just going to go down to here, change that into ask, and now when I go back to the table, you can see it's empty. So in this case, I'm going to put negative 2451, hit enter, and you can see it tells me that the value of y will be 4,914. And now I can just insert another value really quick, 5009, hit enter, and it tells me that it's going to be a negative 10,006, I believe that says. Okay, so you can see that's very convenient. Now to clear these values, I can just move up to that row and hit the delete button and the delete button. And now to go back to our original screen, if you ever get stuck somewhere, just hit the second mode, which is the quit. So second quit brings me back to here. And when you're in this screen, if I was typing something in, I'm like, oh, I made a mistake. I can use the back buttons and the delete buttons and stuff, but I can also press clear to start over. And it's just going to clear that one line, okay? And I can now put in the real one, but if I press clear twice, you're going to clear the entire screen right there. All right, let's move on to the second question or equation, which is going to be y equals, now remember we're substituting x and trying to solve y here again, so it's going to be 2, it's going to be 2 and then x squared minus 5x minus 2. And now I'm going to substitute a 3.5 in there and a 3.5. So again, if I'm on my calculator, just a standard calculator, I can just punch this in exactly as I see it. So 2 bracket 3.5 bracket squared minus 5 bracket 3.5 bracket minus 2, hit enter, and you can see that when x, oops, where are you going? When x is equal to 3.5, that y is equal to 5. And again, we could do the same thing by going into our y equals right here and doing the same, punching in that equation. Now I can clear the original one, the y1, or I can go down to the next line and I can put this in again, which would be 2x squared minus 5x and minus 2. And now when I go to the table, and what was the value that we had, 3.5, hit enter, you can see right here that it's giving me the value of y1 and y2 is 5. And if I put in negative 125, it's going to give me the values of the y graph and the values on the y2 graph. Okay, now what if we're asked, like question 4a says, well, this time I'm going to give you y, and what is x? Okay, well, if it's a linear equation such as this, it's actually fairly easy just to, again, substitute the value in and do some basic algebra. So I'm starting off with y equals 7x minus 3. I want to solve x when y is equal to 8. So 8 equals 7x minus 3. And now all I essentially have to do is get all the x values on one side and all the numbers on the other side. So I'll start off by adding 3 to both sides, eliminating the 3 on the right, and leaving me with 11 on the left, and I still have that 7x over on the right. Now I don't want to know what is the value of 7x's, I want to know what is the value of 1x. So to convert 7x's into 1x, I just divide it by itself. 7 divided by 7 gives us the value of 1x. And because I do this on one side, I have to do it on the other side, and so essentially I get 11 over 7. Now, if I again go back here to our main screen, and I'll clear this, and our answer is 11 divided by 7. I can punch it in that way, but I can also punch it in as a fraction. And if I hit enter, you can see it gives me a decimal value right here. And now if I go into math, and I hit the arrow button and go over here to fraction, and then just hit the 1, it allows me to put in a fraction. So I'm going to go 11, hit the arrow down, 7, and enter. It gives me that same value right there. Okay, now what about using the graphing calculator? Like, how would I do that? Well, you're going to go into y equals, and in this case I'm going to clear both of these, and I'll go back and punch in my original equation, which was 7x minus 3. And that's going to give me a graph that gives me a straight line like that. Now what I want to do is I'm saying y equals 8. Well, that is an equation right here, so I'll go to the y2, make a second graph where y is equal to 8, and if I graph that, I'll get 2 lines. And right here at that point, that's like an intersection between these two graphs. So this is y equals 8. So at that point where they intersect, I can find the value of x at that intersection point. So what you want to do is go second, trace, which gives us the calc. And what do I want to calc? Number 5, which is an intersection. And you can see I've got this flashing little cursor on the blue line. I just hit enter, it jumps up to the red line. I hit enter, it says guess. I hit enter again, and it now tells me and stores the value of x into your calculator. So it says x is equal to 1.5714286. Now, if I go back to my main screen, second quit, if I just press the X right there, remember we stored the value into the X, and I hit equals, it tells me it's 1.5714 da-da-da. Now if I want to, if you're asked given an exact value, it's going to need to be not in a rounded decimal form, but in a fraction form. Okay, so in this case, what you're going to want to do is hit the math, go to math, and move over to the fraction right here. And this number 1 is, no, I'm in the wrong spot. Sorry, wrong spot. I want to be in the math and just hit 1. So it's basically saying arrow fraction, so 2 fractions. So I'm already in decimal form, change it into a fraction. So if I hit 1 and hit enter, it takes my value that I extracted from the intersection on the graph as a decimal, and I can now convert it to an exact value in fractional form. I can also come down here and choose my y, which is right here, this little green y. So if I go here and go alpha 1, it's going to press a y, and if I hit equals, it's going to say 8. So basically, when y is equal to 8, x is equal to 11 over 7. Okay, now let's move to the next one right here, which is going to be a little bit more complex because I've got an exponent here of 2. So that means I'm going to have 2x values. So let's take a look at this again. Y equals x squared plus 2x minus 15. Okay, now it tells me to solve when I'm given the value y equals 3, what is x1 and what is x2? Okay, now to do this on the calculator is quite simple. I'm just going to clear this, go back to y equals, and I'm going to go down to here, clear and clear, punch this in, which is going to be x squared plus 2x minus 15. Go down to the next line and we have y equaling 3. If I graph that, I should get a parabola and a straight line where y equals 3. And we have two intersection points, one here that's in the positive x and one over here in the negative x. So to calculate those 2 points, I just need to use the calc button again. So second trace, intersection, which is 5. And now what I'm going to do is I'm going to sort of move around here and just come over to this side. So I'm on the blue line over on the negative side. I'm going to hit enter. It jumps down to the red line, hit enter, and I hit enter again. And now I've got a value of x is negative 5.35. So I've got x equals negative 5.35. Okay, now if I now go to second calc again, and 5, which is the intersection, I'm going to want to swing around to the other side. Here we are. And I want to go on that line, jump down to the red line, and hit enter again. And it tells me that y is going to be 3.35. So I mean x, sorry, is going to be 3.35. So those are my two values of x when y equals 3. Now, if those happen to be something I can convert to exact value, again, I can just go back here to the main screen and I can check out my x equals, and it gives me that fraction. And again, if I go math, convert to decimal to fraction, hit enter, you can see in this case it came up and wasn't able to give me a perfect answer. So in this case it can't be represented as a fraction, so which means that it's probably going to have it's probably going to be represented in some type of radical form. Now to calculate this one by hand is definitely not that easy, because you're going to be going y, substituting with 3 equals x squared plus 2x minus 15. I'm going to want to make the y into equal to 0, so the left side equal to 0, so I'm going to not add 3. I'm going to subtract 3 from both sides, and now I end up with 0 equals x squared plus 2x minus 18. Now, this one happens to be not factorable. If it was factorable, well then I would be able to calculate my two different values of x. And I'll give an example of that right after this. But other than that, you're going to have to go in and use what's called the quadratic equation. So in here, in front of x is a value of 1, and it's a positive 1. So this happens to be the value of a, that happens to be the value of b, and that is the value of c. And the quadratic equation is like this. So x is going to be equal to negative b plus or minus the square root of b squared minus 4 times a times c, and all of that divided by 2 times a. So if I was going to choose one of them, so I'll choose plus right now, I would just have to substitute all those values in there. So it's going to be like x equals, and in this case it's negative b, and what is the value of b? Well, the value of b is positive 2. So it's going to be a negative 2 plus the square root of b squared. Again, what is b? It's 2, so 2 squared minus 4 times a, which is just 1, so really it doesn't change anything, and times c, which is negative 18. That all falls under the square root symbol. And then I'm going to divide all of that by 2 times a, which again happens to be 1. Now if I go back to my calculator, I'll turn it on, clear the screen, and we're going to want to set up a fraction in this case where I'm going to say math, slide over to fraction, and 1 is what I want. So I've got my numerator and denominator, and up top I'm going to go negative 2, and in this case I'm going plus, and now it's going to be the second square root of 2 squared minus 4. I don't need to put in times 1, but I will put times negative 18. And now I need to jump down to the denominator, so I just hit the arrow down, and it's 2 times 1, which is just 2, and hit enter, and you can see that we get 3.35. So that is how you would calculate that by hand, and it's fairly simple to do. Once you have the formula, you just really need to remember that this is A, this is B, and that value is C, and has to be set to 0 and put into this format right here. Now I'm just going to show you basically taking that same equation, which was x squared, y equals x squared plus 2x minus 15. So y equals x squared plus 2x minus 15. So most likely what I'd end up doing is modifying a question like this and making it equal to, say, a negative 12. And I'd say to you that y equals 3. Now solve for the two values of x. So in this case, you would replace y with 3. You'd still have x squared plus 2x minus 12. You would go minus 3, minus 3. On the left side, you've got 0 is what we're looking for. I've still got an x squared plus 2x. And now I've got a minus 15. So in this case, I'm going to be able to factor this into two binomials. That is going to be equal to 0. So I've got x and x. The signs are different, so plus and minus. What multiplies to 15? It's going to be 1 and 15, 3 and 5, and they need to subtract equal 2. That's going to be these two, and the largest of those numbers is going to be positive, so I'm going to put a 5 right here and a 3 right here. And remember, we could break this down to x plus 5 equals 0. Therefore, x is equal to negative 5, and x minus 3 equals 0. Therefore, x is equal to positive 3. So in this case, we started with an equation that would allow it to be factorable once we substituted the given value of y into there, and then you were able to come up with a factorable value of x in both cases. All right, everyone, let's take a look at this question. It's number 6a, and basically they're asking us to graph this function, which happens to be y equals negative 3 minus x, but we want to put that in the form of y equals mx plus b. So we just need to take these two numbers and sort of flip them around. So this would be better written as y equals negative x minus 3. And they're asking us for exact values, and right here you should be able to recognize that once it's in this format of y equals mx plus b, that the constant is going to be our y-intercept. So our y-intercept is negative 3. So down the y-axis, 3 units, and that's where it's going to cross right there. Okay, so we know that at the y-intercept, x equals 0. So at the x-intercept, we know that y equals 0. So to solve for the x intercept, we're just going to replace the y with 0. So we get 0 equals negative x minus 3. And I just need to isolate and solve for x. So I'm going to add 3 to both sides. And now I've got 3 equals negative x. And you should recognize that we're not looking for a negative x value. We're looking for a positive x value. So if negative x equals 3, then x is going to be equal to the opposite of that, or negative 3. And essentially what we're doing here is we are taking the value that was in front of the x, which happens to be a negative 1, and dividing by negative 1. Negative 1 divided by 1 is going to be a positive 1. So the value of 1x equals, and in this case, negative 3, but we just never write that 1 right there. Okay, so our x-intercept happens to be negative 3 as well. So 1, 2, 3 on the x-intercept, and we've got a point right there. And we are now going to have a line that is going to go through those 2 points and off in either direction forever, so infinitely. If I go back to this one up here, how do we know that this is true, that the constant is the y-intercept? Well, remember at the y-intercept, x equals 0, so I'm just going to substitute x with 0. So I get y equals 0 minus 3, or negative 0 really, but it doesn't make a difference. So that's eliminated, and we just end up with y equals negative 3, which we put into there. Now, what about on the graphing calculator? What can we do with that? Well, let's turn it on. We'll go to y equals. We will put in negative x minus 3, and we'll hit graph. And this is showing that our graph is correct. So we're using the calculator to quickly verify that what we have done is right. Now you can go to second table. And in this case, I'll just delete both these values right here. And remember what I showed you. You can go to table set and actually set the independent to auto. And when you graph that and look at the table, it's going to give you a list of all the values starting at wherever you told it to start. So if I go back here to the table set, it's saying to start at 11. Usually we would want to start that at, say, 0, or wherever you want to start it at. If I was looking for the number negative 200, I could start at negative 200. Now if I graph that and go to the table, starts at 0, and that allows me to see here that at 0 in the x, that is our y-intercept at negative 3. And we figured out that our x-intercept is negative 3. So if I just move up here to negative 3, if that's true, then the y value should be 0 there. Okay. Also, when I'm at the graph, I can just type trace and hit 0 and enter, and that will find your y-intercept for you. You can see when x is equal to 0, y is equal to negative 3. Now to figure out the x-intercept, which is over there, it looks like it's going through the negative 3, but it could be a little to the left or a little bit to the right. So to do that, we're going to go second trace, which is calc. We want to calculate the 0 value. Which 0 value? The 0 value of y at the x-intercept. So it tells me to go left bound right here. So I'm going to go a little bit left of that, hit enter. It tells me to go right bound, so I'm going to go just a little bit right of that point, press enter. It says press enter again for this guess, and there it is again. When y equals 0, the x-intercept will be negative 3. Okay, so let's move to the next one. And it's just a little bit more complex, but still fairly easy to solve. So in this case, we have y equals negative 4x plus 6 over 3. And remember, we're trying to get into the form of y equals mx plus b. So you should be able to recognize that this can be rewritten as negative 4x over 3 plus 6 over 3. So essentially, this, remember, is my slope. This is my y-intercept. This is just an x-coordinate, and this would be its corresponding y-coordinate. Okay, so we have all of that right here. We just need to simplify some of this. So you can see that 6 over 3 can break down to 2. So what we have is y equals negative 4 over 3x. So the slope is negative 4 over 3. And the b value, or the y-intercept, is going to be 2 and a positive 2. So that is going to be our y-intercept right here. It's a positive 2. So 1, 2, and there's my y-intercept. Now, how do we solve the x-intercept? Well, again, at the x-intercept, y equals 0. So I'm just going to replace the y in this case with 0. So I get 0 equals negative 4 over 3x plus 2. Okay, and what we got to do in this case is eliminate that, remove the denominator right there. So I'm just going to take everything and multiply it by 3. So 0 times 3 gives me 0. Then I have negative 4 over 3 times 3 is just going to give me a value of negative 4. And the x needs to stay there. And this last one, which is 3 times the positive 2, is going to be a positive 6. Okay, so now we want to take this 6, move it to the other side so that we can begin to isolate the x. That eliminates that. And now I'm left with negative 6 equals negative 4x. And I'm going to divide both sides by negative 4. And I'm going to get an elimination right there. And I've got x equals negative 6 over 4. And we should be able to see that we can reduce this down to a negative 3 over 2. Or it can be a negative 1 and 1/2. Or it can be a negative 1.5. Okay, so in this case, I've got a negative 3 over 2. Okay, and that's going to be the x-intercept. So negative 3 over 2 is between negative 1 and negative 2. So there's negative 1, negative 2, and our x-intercept is going to be right there, meaning our line will go through those 2 points and off in either direction. And to verify that all of our work is correct, we're just going to jump over to the calculator, go to y equals, I'll clear that one. Now to input this original function, which happens to be in a different format, I'm going to have to use the fraction function on the calculator. I could use our rearranged formula, but what if I made a mistake when I did that? So it's really easy to put a fraction in here. You're just going to go to math, and then there is a button that says, or a sort of menu item right here that says to fraction, but that's to convert from decimal to fraction. What we want to do is go to this little menu right here, so I can move over to the right or just once to the left and just choose this one, which is a numerator and denominator, number 1, and you can see it creates a fraction for me right there. And I'm just going to type negative 4x plus 6, and now I need to hit the down arrow to go into the denominator, and that's over 3. And again, I can graph that, and I get a line that looks like this. And I'm wrong. What did I do wrong? Okay, so it looks like I got the right slope. I've done something wrong. I've got I created a positive slope, and that happens to be a negative slope. Negative 4 plus 6 over 3. Go back to my y equals -4 plus 6 over 3. Let me see where I went wrong with my math then. So I'm going to go -4. Okay. So I can see where I've made a mistake. So you can see how the calculator actually comes into play right here. Right here, I was dividing both sides by -4, but on the other side I forgot to put the negative right there. And if I divide by -6 by a -4, I'm actually going to get a positive 6 over 4, or a positive 3 over 2, or a positive 1.5, or a positive 1.5. So that changes my graph right here, where I'm going to have the the Y-intercept right there, and the X-intercept is going to be in the middle right there, giving my line like this. I'd like to say that that was an honest mistake to show you the value of the calculator, but it was just a mistake. Damn. Okay, now remember, we can also go to the table, and if I scroll up the table until I find, or down the table until I find 0, I can see that there is my Y-intercept, positive 2, so that's being verified. And now to solve for the X-intercept, I know that it's 1.5, but you can see that the table of values is skipping by 1 in each case. So if I go back to my table set, and I'm going to just go down here, and I'm going to say ask. I believe I can also set this to 0.5. That should work as well, and leave it on auto. And then if I go to the table, it's going every 0.5. So in this case, I would want to find 1.5 on the X, and that should be right here where Y equals 0. Okay, and don't forget, you could also go to the table set, come down here, go over to ask, go back to the table and type in 1.5, hit enter, and you can see that at 1.5x, that is our Y-intercept. All right, so we're going to attack a couple questions right here, number 7a, and what you need to recognize is that this is not a linear equation. It's a quadratic equation, which is going to form a parabola, and that's identified by having this x squared value right here. And notice in that case, we're going to end up with some shape like that. We're going to end up with one y-intercept, and we're going to end up with two x-intercepts. And that's denoted right here with the S. So the X-intercepts. Now, there possibly could be 0 X-intercepts if the parabola was to start right here and go up, or start right here and go down. Okay, so let's just see what we end up with right here, and let's lay this thing out. Okay, so y equals x squared minus 5x minus 6, and we know that as long as it's in this format right here, that value is my y-intercept. So negative 1, 2, 3, 4, 5, 6, that is where my y-intercept is going to be. Now, we need to take a look to see where my x-intercepts are going to be, and to do that, I just need to factor this thing out. So if I look at this one right here, 6 breaks down into 1 and 6, and 2 and 3, and I need to subtract equal 5, which would be these two, and the larger number is going to be, it's going to be negative. So this one will easily break down into x minus 6 and x plus 1. Now remember, we're trying to find the X-intercepts, and we know what the X-intercepts, that y is equal to 0. So we're going to substitute that y with 0, and then we're just going to isolate each one of these. So I've got x minus 6 equals 0, therefore x equals 6. And I also have x plus 1 equals 0, and therefore x equals negative 1. So those are my two values for this. I've got a negative 1. So I got a negative 1 and a negative 6. So in order for us to verify this, we're going to want to can't be negative, it's going to be positive. Sorry, almost made another mistake there. It's going to be positive 6. So 1, 2, 3, 4, 5, 6. It should be going through that point, and negative 1 should be going through that point right there. Okay, now let's just head over to our calculator and check this out. So I'll delete that. I'm going to put in the original equation, which is x squared minus 5x and minus 6. Graph it, and you can see it comes down and back up. So it looks exactly like what we were, what I've got started on the graph right there. Okay, now what we want to do right here is readjust our windows. I can't see the bottom of this. Okay, so if I go into window, now that means if I can't see the bottom of that, it means I need to go down in the y. So I'd move down to my y min, and I'd change that to, like, say, a minus, I don't know, 18, and graph it, and bam. Okay, so now I've got this graph that's coming down through here, through that one, down at some point, and then it goes back up, and it'll go forever in those directions. Okay, I'm going to show you one other thing that we can, well, a few things that we can do on this calculator right here. So again, if I go to my table set, and I can see that everything's sort of an integer value, so I'll just start my table again at 0, and I'll set the table increments to 1, and I'll set the independent variable to auto, and then we'll go to the table, and at 0 right there you can see that that is negative 6. So 0x negative 6 in the y, that's correct. And then if I go down to find my x-intercepts, they're going to be 6 and negative 1. So when I find 6, you can see that the y is 0. And when I go up here to negative 1, it is also 0 right there. So the calculator has given us the shape of the graph. It's confirmed all our calculations on the table. And remember, we could also go into the graph and calculate these 0 values as well. So remember, if I just go trace 0, enter, it's going to tell me that at x equals 0, y equals negative 6. If I go second, calc, I'm trying to find the 0 now on the x. I would want to go up, so I'm a little bit to the left, press enter, go down, so I'm a little bit to the right, enter, enter, and it gives me the value of y 0 and x negative 1. And if I do that again, 2, go to the other side this time, and it says go a little bit left. So I'll go a little bit left right there, and a little bit right there, and hit enter, and it gives me the other one, 0 and a positive 6. Okay, we have one other thing that we sort of need to know, and that's like, what's that point right there? Okay, now if we take a look at it, that parabola is sort of symmetrical, so it's going to be in the x value, it's going to be halfway between that point and that point. So if this is negative 1 and this is a positive 6, we've basically gone 1, 2, 3, 4, 5, 6, 7 spaces. So the x value at this sort of minimum, we call this the minimum right there, the lowest that the graph can go, that's going to be a 3.5. So to figure out the y value, I would just replace the x in any one of these equations that I have up here with that 3.5, and I could solve for the y value. So let's try that really quickly. So I get y equals 3.5 squared minus 5 times 3.5 minus 6. So I would just go over to my calculator, and I'm just going to punch it in exactly like I see it. 3.5 squared minus 5, 3.5 minus 6, and hit enter, and it tells me that would be a minus 11.25. Okay, and that looks good so far. According to my graph, I am down negative and I'm past the 6, so 11.25 sounds good. Now remember, I can also go back into my table and go to my table set, and again, because it's a 0.5, I could just come down here and say, well, let's just ask the table, if it is 3.5, then what is the value of x? And it says negative 11.25. So I verified using the table again. I can also go and verify it on the graph by using some of these calculation functions right here. So if I go second calc, what I remember, I called that the minimum, the lowest that it went on the graph. So I'm going to say, what is the minimum? 3, and it tells me to go left bound, so I'm going to go left of the minimum, which is just over here somewhere. Enter, go to the right of the minimum, right there, and hit enter again. It's going to find the bottom for us, which is y equals negative 12.25. So why do we have negative 12.25? Okay, what did I do wrong again? Okay, okay, I see what I've done wrong. Now, it is 3.5 over, remember I said between these 2 points right here, we've got a difference of 7, so we would move over 3.5. But because I was starting at negative 1, I went over 1. That gets me to 0, and then 2, 3, 3 gets me to the 2, and then a 0.5. So actually this is not 3.5, it's 2.5. It's a careless error, again, which means that is not going to be that value of 11.25. And to verify that the math still works, I would just replace these values with 2.5. Okay, so I'll go back to my calculator, go in quit right there, and remember, if I hit second and enter, I can bring this back in there and use the insert and delete keys, or I can just paste that back in there. So if I go delete that, insert a 2, and go back to here, and delete that, and insert a 2, and hit enter, and I get negative 12.5. Okay, so again, another honest mistake, and the calculator is, again, it's your friend. It's there to verify all these calculations that you're doing. Okay, so if I go back to the table, remember I got it asking here, and this is true at 3.5, the y value is negative 11.25, but our minimum is at a x value of 2.5, and you can see there it verifies it, that at 2.5 the y is going to be negative 12.5. Okay, let's move to the last one and see if I can do this without making a mistake this time. All right, so this is 7c, and we're starting off with y equals 2x squared minus 7x plus 8. You can see that that x right there is raised to a power of 2, so we are going to have a parabola, and we need to now determine the y-intercept first, which is right here, so positive 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that is where our y-intercept is going to be. And now we need to basically take this and see if we can factor out this 2 that's right here. So can we get rid of that 2? And the answer is no. So now we want to see, well, can we factor this any other way? So I'm basically going to take 2 times 8, which is going to be 16. 16 breaks down into 1 times 16 and 2 times 8 and 4 times 4. And those numbers will need to add together to equal 7, which cannot happen right here, cannot happen right here, and cannot happen right here. So using the methods we've learned so far, this is not factorable. So the only way for us to calculate the X-intercepts again is to use the quadratic formula, which is going to be x equals negative b plus or minus the square root of b squared minus 4ac, and all of that is going to be divided by 2a. And remember that once we've got this set up, that is my A, that is my B, and that is my C. So in this case, A is equal to positive 2, B is negative 7, and C is going to be a positive 8 right there. Just delete that, give ourselves a little bit more space, move this up a little bit. Okay, so in this case, all I have to do is substitute those values in there and start off by selecting one of these values. So negative b is a negative 7. So that's going to be a positive 7. So x equals a negative 7, which is a positive 7, plus the square root of b squared, which is a negative 7 squared, minus 4 times a, which is 2, times c, which is 8, and all of that is going to be divided by 2 times a, which happens to be 2, and now you just need to punch that in the calculator. So if I turn this on, we'll go to this function right here, clear the screen. Okay, so let's punch this in. I get a negative 7, so really that's just a 7. But notice that that is set up as a fraction, so it's probably best if we go into math, move over to the fraction menu and select number 1. And then I can start off with a 7, negative 7, but I can also just punch it in exactly like I see it right there. It's still going to work. So I got a negative 7, in this case, plus the square root of bracket negative 7 bracket squared minus 4 times 2 times 8. Drop down to the denominator, and that's a 2 times a 2, and hit enter, and we have a problem. So let's go back to here, and it's giving us an error. So what that's probably telling us is that this graph is actually not going to cross through this. So it's either going to go like that or something like that, or like that, whatever. Some way it's not going, we have no x-intercepts, or I've entered it into the calculator wrong. So again, it's good to go into our graphing function right here and just punch in the original equation, which was 2x squared minus 7x plus 8, and graph that. And yeah, you can see that it doesn't come down and intersect with the x-intercept. So in this case, there are none. Okay, now because I don't really need anything down here, to see this better, I would go into my window, and my Y minimum, I'd probably set that to like, say, -1 or something like that, just below it. Graph that again. And you can see I've got a little bit better of a view here, and I'm also not going too far to the left, so I might go back into the window, change this to a -4 or something like that, and graph that again. Looks pretty good. And I want to be up a little bit more, you know, just so I can see that point right there a little bit. So if I go back into window, that's my Y max. So instead of 10, I'll choose 15. Graph that again. Oh yeah, that's looking good. Okay, so our graph is looking something like this. It's coming down and then hitting that point, going back up like that. Now what I want to find out again is what is that minimum point right there. Now in this case I don't have any X-Intercepts that I can use properly. So I'm going to use the function in here, which is the minimum. So I'm going to go to second calc, the minimum, which is 3. And it says go a little bit left. So there's left, a little bit right. There's right, enter. And it says I'm down at a value of X of 1.75 if I rounded that to the hundreds, and Y of 1.88. So this value that's down there would be a 1.75 comma 1.88. Okay, so that's a long video, and I've gone through a lot of the skills that you're going to need in this unit, and some extra things as well. Definitely you need to be able to use all of the hand math as well as the calculator math in order to be successful with this unit. So here you go, enjoy, and we'll see you in class.